Yeah, let's get started on averages, guys. Averages and mixtures. What do you know about averages? What is average in general? When you hear the term some number upon count. Yes, indeed. So average is arithmetic mean. We always think of arithmetic mean when we talk about average, although average is a very relative kind of term. But we generally think of average as arithmetic mean. And a number that gives us an idea about a group. You can say that. You can say that in terms of statistics, that is what statisticians would have said. It's a measure of central tendency, giving us a kind of center of the group. And CLT, Anubhav, I don't know what CLT is. Central limit theorem. Yeah, that's getting into central line tendency. Okay. Yeah, there's a subject. There is another theorem. I think CLT is reminded me of that theorem. But yeah, nevertheless, we are not getting into great concepts of statistics. What we will focus today on, we focus on averages, we'll focus on mixtures and on alligations. There isn't a lot of difference between mixtures and alligations per se. And I will focus on the I'll focus on the simplest way of calculating averages for different mixtures. And I'll probably give you a formula too. I mean, we'll base that on the formula. So yeah, basic concepts on averages. Of course, average is sum of all elements upon number of elements. These elements could be anything. These elements could be weight. So the average weight of a class would be sum of everyone's weight divided by the number of students. This could be the average age of a class, or the average age of, I don't know, the average age of a group of people, average amount of savings, average, we calculate GDP per person. So there are many ways of calculating averages, but it finally is, as the formula shares, sum upon number of elements. We will talk a bit about, understanding average as a value at which the sum of deviations is 0. This is very interesting, very important, and helps us solve calculation in general. And then we'll talk about average of numbers in AP, which is incredibly direct, very simple. So let's jump to understanding average as 0 deviation. Now, when I say average is 0 deviation, what I essentially mean is, look at the figures here. You have all values on your screen. Say I have these 4 numbers, 32, 41, 62, 65. Say they are the ages of 4 people in a group. Yeah. If you calculate their average, it is going to be 32 plus 41 plus 62 plus 65, which comes out to be 400. Which means the average is 400 by 50. This is 50 because it's 200 divided by 4. Yeah. Sum of everyone's age is 200. You divide that by 4 people present, you get average age 50 years. Now, I can also understand average as a concept that says, if my average is 50, it essentially means that the amount by which the two here, so the amount by which the entities that are less than 50, the total amount, so 32 and 41 are less than 50, 32 is less than 50 by 18, 41 is less than 50 by 9. So this minus 27, the total sum of their deficiencies, their differences, is going to be the total by which the other two are extra. So 62 is more than 50 by 12, 65 by 15. So, it's the same. Plus 12 plus 15 is again 27. So that is essentially what average can also be seen as, that the amount by which the entities that are less is equal to the amount by which the quantities that are greater than average are more in total, in sum. Yeah, so average essentially averages that limit at which the sum of the differences from means comes out to be 0 for the whole group. Yeah. How does that help? That helps us, say, for example, if I had to calculate this question, if I had to solve for this question. Now, what can I do here? How can I? Could you tell me the average for these 4 values? Yeah. What can I do here, guys? What can I do here? How can I use the concept shared in the last slide here? 6569.25, my dear God. How is that possible? If my 4 values are all in the 4000s, how is 6000 a possibility? In fact, even 4569 is not a possibility. Yeah. What you can do here is, what you can do here is have a look at the 4 numbers and choose any number close to the 4, that you feel could be the average. And I generally recommend taking a smaller number. 430 is absolutely correct. What you could have done here is you could assume the average to be, say, 4300. Make or band. Assume the number to be, the average to be, say, if I look at the 4 values, let me take 4300 to be the average. And then let me see what the difference from the mean is. So, yeah, so say 4350. When I did it first, I took 4350 and I made a slide with this. I've assumed the average to be 4350 and seen that for these 4 values, the differences coming out to be are plus 202. I just assume, just take any number. Take any number that you feel could be the average. You could have taken 4300 here. Yeah. So I was talking about taking 4300, but yeah, I've calculated and done this for 4350 and shared it through a slide. So let's talk about 4350 here. Take any number and then have a quick look at the difference from the mean. Of course, if you want to take a number close to these 4 so that your calculations are minimized. You obviously want to solve this as quickly as possible in the least amount of time, making as little mistake as possible. So the 4 numbers are different by 202, minus 145, 6, and 57. Just add them up. If you just add the 4 of them up, you get a total sort of difference. The sum of differences equal to 120. Now, what does that mean? What do I want to tell you here? What I want to tell you here is, say, these were savings of 4 people. Savings of one is rupees 4552, of the second rupees 4205, and 4356 and 4407. If you just assume that they have sort of kept all the money on the table, and initially they've all taken 4350 each from the table, from the total that they have, from all the sum, then what you would have left on the table is 120. 120 rupees would still be left on the table, and for them to be equally divided, which is what average is, you divide 120 by 4 and get 30 each. Yeah. So my mean will become now the assumed mean 4350 plus the extra bit, which is 120 by 4, 4380. So that is what I'm doing here. Just take any number. I will repeat that. I have just taken any number as the average, then seen what the sum of all differences is. What is the sum of all differences from this assumed mean 4350? Now, whatever the sum is, I divided that by 4, which is the number of people here. And this will give me the new average, which happens to be, since the sum of all differences was 120, divided by 4 is 30, my new average came out to be 4380. Yeah. So, yeah, I hope this is clear. And let's try to use that for this question. So let me show you this question as an example, question number 1. And then you can try question 2 and the rest of the question. We have lots of questions on this. Say the average weight of a batch of 16 students is 45 kgs. If 2 students of weight 69 and 57 join, then what is the new average? Now, can I not see this question as, based on the same concept? Say I have these 16 students. Instead of kgs, let me just say they have chocolates. See, whether it's 45 kgs or 45 rupees or 45 chocolates, it doesn't matter. We are concerned about numbers, not what the numbers here represent. Not for the time being. So if all of them had 45 chocolates and 2 people join in, one had 57 chocolates, and I think the other had, so one more person had 69. Let me check if this is what the numbers were. Yeah, one had 57, one had 69. The simplest way of calculating this average. Now, the formula, the way you could have calculated this by formula would have been, average would have definitely been 16 people with average number of chocolates 45. So total number of chocolates 16 into 45 plus 57 plus 69 by 18. This would have been absolutely correct. But this will also involve pen and paper and time. Yeah, the simpler way here would be to sort of rearrange these numbers, to manipulate these numbers by getting everyone, all 18 of these people, at the same average value. What do I mean? Instead of 57 and 69, let's say the first person keeps 45 chocolates with him or her and gives away 12 chocolates. And the second person also keeps 45 chocolates with him or her and gives away 24. Yeah, so assume, like each of the 16 people had 45 chocolates in their bag. Then the 2 people who join also keep 45 chocolates in their bag and keep the rest on the table. If you can assume it, imagine it physically. What that would mean is now you have an extra number of chocolates on the table. How many? Plus 12 plus 24, you have 36 extra chocolates. And a group of 18 people who all have 45 chocolates each. So obviously, the new average is going to be 45 that everyone already has, plus 36 extra divided by 18, which is 2. My new average comes out to be 47. You don't need a pen and paper to calculate this. It takes a minute. Is this clear, guys? Did you understand this? Did you understand this? If you did, I will ask you to try the other question. And let me quickly repeat this. What you can do always is, if you have a group and say, you have 2 individuals here, get everyone, the whole batch, the whole new group at the same level. We made them 45 each by asking the other 2, number 1 here, this person and this person here, to give away 12 and 24 chocolates respectively. So we had 18 people with 45 chocolates each, and an extra 36 chocolates to be equally divided among 18 people. That is what average is, which means with an extra 2 chocolates for to go along with the 45. Therefore, each person now has 47 chocolates. That must be my final answer. Okay, why do you use this approach to solve question number 2? Now, please don't go back to the old method. Please try to solve this using the approach we just discussed. $31,500. I'm not so sure. I don't think you guys have read the question correctly. Kamal and Krishna. 22 people had average savings of 30,000, but the two that leave have more than 32,000 or had more than 32,000. Two people with savings of this and this leave the group. Yeah. So will your average go up or go down? It will go down. The answer can't be more than 30,000 without a shadow of doubt. Let's see if it's 28,400 or 28,500 or something else. It's great. I've had 3 or 4 different answers from even the values. Okay, let's check. It is definitely 28,000. It's not 28,500, unfortunately, Krishna. So let's check what the answer is. You have, so let me go back to the diagram, to the whiteboard. So, again, using it the same way. I had 22 people who all had 30,000. Yeah. Let me rearrange this and say that I had 20 people who had 30,000 and 2 other people who also had 30,000. Let me just keep everyone on the same sort of page for the timing. Now, since these 2 are taking away, what was the number? Let me check again. 42,000 and 54,000. One is taking away 42,000, the other is taking away 54,000. It means that in total taking away an extra from these 20, they are taking away an extra 12,000 and 24,000 respectively, which means in total they are taking away 36,000 from the 20 people. Is this clear? For these two sort of part ways with the group, they take away a total of 36,000 from the 20 people, which means that they take away 36,000 by 20 from each person. If I want average, I have to get what each person gives. I have to see numbers in terms of what the contribution of each person or what each person is receiving, and that here happens to be 36,000 by 20, which of course happens to be 1,800. And since each of them earlier had 30,000 and had to give away 1,800, my average must be 28,200. The average number of savings now is 28,200. Is this clear? There is no way you're going to get any other answer, even if you calculate it like this, the total amount from the total terms. The total amount of money you have is 22,000. 22 into 30,000. This is the total amount of money initially. That must be equal to 20 into the new average plus 42K plus 54K. And you have to calculate A. You will get the same answer. There is no doubt. Why did not take into account 2 extra people in the previous question? We did take into account 2 extra people in the previous question, which is why we increased the number from 16 to 18. The original number was 16 students, but when we finally calculated the average, we said we have 36 extra chocolates to be divided by 16 plus 2, 18. Yeah, and of course, in question number 1, 2 people are joining the group, and in question number 2, 2 people are leaving the group. So when you're talking about the new average, you're talking about the final number of people. Yeah, which in case 1 was 18 finally, and in case 2 is 20. Is this clear, guys? Let me know if you guys have any doubt. Else we'll solve more questions, of course, on this concept. It's an incredibly useful concept. I have to say that, because even questions on mixtures and alligation can be solved if you just focus on the extra part. But let's just talk about numbers in AP first. So I hope you realize that, and you know that numbers in AP are essentially numbers that are at a constant difference. Each subsequent term is at the same difference, from each other term, each other previous term, say. So 1, 2, 3, 4, 5, these consecutive natural numbers are also in AP. Common difference 1, 6, 8, 10, 12, 14. These are even numbers, consecutive even numbers, also in AP. 14, 21, 28, 35, also in AP. These are multiples of 7. And of course, averages for such a group of numbers is always the middle term, if one exists. Yeah. So for example, if I try to talk about part 1 here, 1, 2, 3, 4, 5. The average for these 5 numbers will be 3, the middle term, because there are 5 numbers. However, if I were to talk about the average of the last 4 numbers, 14, 21, 28, and 35, there's no middle term. And thus what you can do is, the average will be always the first term plus last term by 2, or second plus second last by 2, or third plus third last by 2. That is what the average is going to be, because the first plus last is always equal to second plus second last is equal to third plus third last is equal to the middle term if there is one middle term. So if you have 14, 35, first plus last term, their sum is 49, or 21 and 28 are the second and second last term, their sum is also 49. So this will always be a feature of an AP. Always. First plus last term is second plus second last is third plus third last is equal to middle term. And the average is simply this sum, first plus last by 2, or second plus second last by 2, and so on. Is this clear, guys? Is this clear? We're not going to do many questions on this. This is very simple and by direct. Okay, excellent. I don't know if we should do a few questions maybe first. I just throw a couple of questions your way. Yeah, why not? I don't see why you should not try these questions right now. Just try 1, 2, and not 2, 1 and 3. And let me know if you have a problem understanding what is written on the board. It's a bit hazy, to say the least. Just try question 1 and question 3. You could also try question 4 because we've already done profit and loss. So yeah, why not try 4 as well? Although it's not directly connected to what you just studied.
What's in the third line of, or sorry, fourth line of first question?
Let me read
If
out the whole question for you.
okay,
Question one is average age of a batch is 26.5 years, 26 and a half years. The average age of the batch, if the teacher is included, is 27 years. Yeah.
okay,
Now, if the teacher's age is 41 years, then the number of students in the batch must be, that is what you have to find. The number of students in the batch is equal to question mark.
okay. Thank you.
You're welcome. Question one, question three, question four, guys. Okay, guys, let's start discussing. I still haven't received answers from everyone. Any answer to question 4? 28 in B is absolutely correct. What about 4? Lakshay, I'm afraid 1 is to 4 is not the right answer. No. Okay. Question 1. 1 is to 5 is correct. 1 is to 5 is correct indeed, Kamal. And you can, I hope you realize, Kamal, that you're sharing messages privately. So, you'll have to change that. You'll have to change that for, to allow the whole group to see your answer. Quickly want to discuss question 1. Any problem with question 1? Any problem with question 1, guys? So just to bed this into your brains, sort of, just to make sure that this is absolutely clear. Yeah, I will explain in a minute. There is a group of n students, and I don't know the number, which is what we finally have to calculate, whose average age is 26.5. Let me just say, forget about average age. Let's say they have 26.5 chocolates each. Yeah, and assume it's half a chocolate each. It's 26.5 each. And if I include a teacher who has 41 chocolates, yeah, then the average changes. Now, always start, as we had discussed. Now, manipulate this 41. Say this is not 41. Then what the teacher has now done is joined the group and kept 26.5 chocolates with herself or himself and given away the rest. So 41 minus 26.5 is 14.5. So let's say the teacher has given away 14.5 chocolates. And clearly, if now I want to talk about the average for the whole group, for the n+1 people, I have to talk about the 14.5 extra chocolates divided by an n+1. Yeah. And this must now lead me to the new average. So, 26.5, now everyone has 26.5, but along with these extra chocolates, the new average must become 27, which is only possible if the extra chocolates divided by n+1 is 0.5. This total extra divided by total number of people has to be half a chocolate to allow the average change from 26.5 to 27. Where n is, of course, the strength of the batch. Just solve this, you get in a minute, you'll get n is equal to 28. The original strength of the batch has to be 28. Is this clear? This is exactly what we had done earlier. Get that person onto the average, divide the extra by the number of people present now, and because you already know the change is 0.5, increase from 26.5 to 27 average, you get this equation and you get the number. Excellent. Any problem with question number 3? Any problem with question 3? The mix question. Don't. In this question, it would pay not to try to be too smart. Just solve this using. You have 2 liters of mix 1, out of which 25% is honey, which means half liter is honey. And from 3 liters of mix 2, you have 75% honey, which means 2.25 liters is honey. So honey in total is 2.75 liters. You just calculated, on those lines, which means that water, I guess the rest is water, must be 2.25 liters. So because total is 5, if 2.75 is honey, water has to be 2.25. And you can immediately calculate the ratio of honey to water is 2.75 to 2.25. Has to be option B, 11 is to 9. Very, very simple question. Yeah, is this clear?
Can we solve this one using the method that we have been discussing?
Can we solve this using the method that we have been discussing? I
So
think
like,
we can. I think we can. But the problem here is what makes me circumspect is this is concentration.
okay,
When we talk about giving away chocolates, like we were talking here,
right.
it would not have disturbed. There wasn't anything else to disturb. I hope you understand that. But here, if we talk about a honey mixture of 25%, say honey mixture one with a honey mixture two that has 75%, now keeping this at 25% and then giving away the rest of the 50%, I think that can be done. I don't see any reason why this can't be done, although I'm a little circumspect, to be honest.
I tried that. I got a different answer. I got 7/20.
Okay, okay.
So I'm not
7,
sure.
7/20.
Yeah, because I did this and then I added 50, so that there was 50 extra left, and then that, so I was using number of liters as the number of people. So
Uh-huh.
2 plus 3 is 5, so we have to divide that extra 50 in.
So what you will get from here by this approach is the average amount of honey per liter,
Okay,
which will obviously also give you the average amount of water per liter, and now then you need the ratio. Yeah, so I don't know if you've done the calculations correctly. So let's just quickly try this. I don't
okay,
see any harm in trying this. We had 2 liters here and 3 liters here. So yeah, something from inside is telling me this is not correct logically because of the concentration. But yeah, let's just try nevertheless. So let's get this 3 liter thing not at 75%, but at 25%, which means giving away 50% of three liters, which is 1.5 liters. No, yeah. So yeah, the problem here is we are sort of calculating the average amount of honey uh, per solution. I think that is what we would be doing here, which is also actually not wrong. Which is also fine. Yeah, we'll get the same answer. I'm sure we'll get the same answer. So yeah, we now have So what I've done here. Let me explain it again. 2 liters and 3 liters. This was in terms of honey a 25% solution. Since this is 75, let's say this solution keeps 25 and gives away 50% solution of 3 liters. It gives away 1.5 liters. Yep. Now that would mean on average, our earlier average for all 5 liters, sorry, for all 5 liters is 25%. But what we have extra now, so 25% would means that uh, 0.25 per liter, something of that sort. We have an extra 0.25 per liter. Sorry, we have an average of 0.25 per liter, and you have an extra of 1.5 liters in total. If I have to increase the average, I divide this by 5, and I get zero point 0.3 extra. So 25% is 0.25 out of 1. If I'm talking about average, and this is something, of course, we discussed in ratio and proportion, that we always take 25% is 25 by 100 or 0.25. In 0.25, if I'm adding 3, what I get is 0.55 per liter. This is essentially 55% per liter. And we're talking about the average concentration of honey. So if the average concentration of honey is 55%, the average concentration of water, let me call that H2O, has to be 45%. And therefore, in percentage terms, that comes out to be, sorry, in ratio terms, honey to water comes out to be 55 is to 45, is exactly the same. 11 is to 9.
okay,
So yeah, you will get the same answer, but you need to interpret it rightly, because you have to understand 25% is 0.25. And then, of course, 1.5 by 5 liters is zero point 0.3 times sort of per liter. And you add these two values, 0.25 and 0.3, and you get 0.55 per liter, which means out of 1 liter, 0.55 is honey, which means 55% is honey and 45% is water, and you get the same ratio. Read the question.
I was dividing 50 by 3 to get the extra amount, and I was not dividing like 1.5. Sorry, I was dividing 50 by 5 instead of 1.5 by 5.
50 by 5.
Right, taking the I think I'll have to take a closer look at this question again, and I'll have to think
Yeah,
about it
it won't
more.
be 50 by 5 because 50 is in any case percentage.
Okay.
And a percentage needs to have a base. 50% of what? So you're talking about giving away 50% of 3 liters, which is what will give me 1.5 liters. Yeah, is that clear?
Right. Okay. So that means there's like 0.5 liters of honey per liter,
Yeah.
and so we are giving.
Yeah,
Okay.
exactly. 50% is 0.5 liters of honey per liter.
Okay.
Yeah.
Got it. Thank you.
You're welcome. I would not recommend this approach in general for concentration, questions on concentration, but yeah, I mean, they would give you the same answer.
Okay. Thanks.
You're welcome. Question number 4. Any problem with question 4, guys? Any problems with question 4? I want to discuss question 4 nevertheless. So, in what ratio should water be mixed with milk so as to gain 20% by selling the mixture at the cost price? Yes, absolutely. This question is as direct as it comes, because if you're selling mixture at the cost price, if essentially your sales price is the same as the cost price in terms, of per sort of per liter thing, the price at which you bought, you're also selling, then any gain, the gain of 20% here, the profit of 20%, has to be because of the water you've added. Yeah. Which means the 20% gain is equal to 20% extra water added per liter of milk. There is not a shadow of doubt from that, based on what is written. What I mean to say in terms of values is that, if I had 10, if I had 10 liters, if I had 10 liters of milk, and if I'm selling at the same price as I am buying, then how will I get 20% profit? I'll only get 20% profit if in these 10 liters of milk I add 2 liters of water. Because say the price I bought was ₹1 per liter. Let's just say that. So 10 liters of milk would have costed me ₹10. To earn 20%, I must somehow gain or somehow get as revenue, as sale ₹12. That is only going to happen if in these 10 liters that I add 2 liters of water and I get 12 liters that I sell as milk. It's not really milk, but I'm selling this 12 liters at milk at the same rate, ₹1 per liter, and getting my sales as ₹12. And that immediately gives me the ratio between milk and water, these numbers. So for every 10 liter, if I'm adding 2 liters, it means that for 1 liter of water, I must have 5 liters of milk. The question is asking you to calculate the amount of water, the ratio of water is to milk. So 2:10 is your answer, which is essentially 1:5. Is this clear? I think, Krishna, is this clear? Because just in all such questions, 40% profit would have meant that in every 10 liters, you had 4 liters water. This is as direct as it can come, and then you immediately calculate, even if I were to change values now. Okay, excellent. But of course, you must remember this is only, this method is only based on the assumption that you're selling at the same price at which you're buying, which means essentially that the profit percentage is completely due to the extra weight added. Which means extra weight added is 20% of the initial weight present. Yeah.
So how do we know from the question that this is what they meant, that they are selling at the cost price?
It's written. Have a look at it again. Look at it again. In the fourth line, it says, so as to gain 20% by selling the mixture at the cost price of milk. You are selling this fake mix, this water plus milk mix at the same price, at the cost price of milk. So if I'm buying at 1 rupees per liter, I am selling it at 1 rupees per liter as well, except that it's not the same. I mean, the concentration has changed.
Okay.
Yeah, that's implied 100%.
Thanks.
Okay, then in that case, let's jump to the weighted average concept, the concept of allegations that we'll use for allegations as well. And I think what I need to do here is just quickly talk about what I mean by weighted average, first of all. Weighted average finally is also average. It's nothing but average. But this term weighted average, this term weighted generally denotes that you're talking about average of groups of entities. Yeah. To take the simplest example would be to talk about. Do I have a question on this? Yeah, this question. Oh, sorry. One sec. This question, guys. Why don't you quickly solve this question? Question number 1. Just focus on question 1 for the time being. Please solve question 1. Any answers? Any other answer, guys, to question number 2, except the one that Chandana shared? 54, 46. Yeah.
It's Chandana, sir.
Okay, cool. Let's talk about the two questions and also talk about maybe an alternate approach and also talk about the formula that I had in mind. Question number one. I hope what is absolutely clear is that the average here is going to be 20 into 45 plus 30 into 60 divided by 50. Yeah, your total score divided by total number of students is what your average is going to be, which is of course 54. Yes, is this clear? Now, is there any other way I could have seen this? Absolutely yes. Yeah, I'll come back to this. You know, the what is on the board. I'll come back to the formula later. But I had I mean, this is what weighted average essentially is. You know, the quantity into the average of the first group, the quantity or number of elements in the first group into average of first group, plus quantity or number of elements into average of second group upon number of elements in group 1 plus number of elements in group 2, which of course happens to be 54. Any way of you solving this without using pen and paper? Absolutely yes. The same method that we talked about earlier. Your 20 students with, let's say, 45 chocolates, another 30 with 60 chocolates. Forget about their 60. You only ask them to hold on to 45, and you give away you take away or ask them to give away 15 chocolates. So what you have in the end is you have 50 people with 45 chocolates each, and an extra 30 into 15. You have an extra sort of group of 13 to 15 chocolates sort of lying on the table, which now must be shared equally by 50 people. Yeah, you've taken that extra chocolate away, and now redistributing among the 50 people, you find that if you solve this, you'll get 9 extra chocolates. So from 45 that each had, you have 9 more. Of course, you now have 54 chocolates on average with each of the 50 people. Is this clear? Exactly the same as we had discussed. Simple, quick. To be very honest, if you become comfortable with this, you can use this. You can solve this using without using pen. Okay, cool. Question number 2 was exactly the same. If you want to use the formula or the formula, say method number 1 and this method number 2, it's exactly the same. But let me go back to the formula. Let me talk about weighted average and alligation a bit. And maybe I can quickly talk about where they come from. So, focus here, please, on this. 54 is the average, yeah? So let me call this the weighted average. Weighted average is essentially nothing but sort of quantity 1, which is 20 students here, into average of group 1 plus quantity of group 2, number of students here again, into average of group 2 upon quantity 1 plus quantity 2. If you rearrange this, if you cross multiply Q1 plus Q2 with weighted average, WA is weighted average, and then you just rearrange this a bit, you will get something like this. Q1 by Q2, the ratio of the quantities is always equal to, so how we do this is if Q2 is in the numerator, then on the right hand side, the numerator is going to be the difference of the average of quantity 2 and the weighted average. So this difference, and if Q1 was in the numerator on the left hand side, then the denominator on the right hand side is going to be the difference of the weighted average with the average of Q1, which is going to be weighted average minus average of A1. This is what the formula, essentially the formula in all concepts revolving around weighted average and alligations are. So the ratio of quantities is nothing but the inverse of their difference from whatever weighted average exists. And of course, weighted average will lie between two extremes, which means, for example, say if average 2 was greater than average 1. Let me just assume here that average 2 is greater than average 1. Then weighted average is going to be greater than A1 but less than A2. It will always lie between the two values, right? For example, in the question below, you had an average score of 45 for the first batch and an average score of 60 for the second batch. For average, 54 has to lie between 45 and 60. It can't be less than 45, it can't be more than 60. Is this clear? Is this clear, guys? How could I have used that for this question? Or just to make sure you understand what I'm talking about. The way I could have used it for this question is, oops, sorry. I had quantity 1, let's say, Q1 was 20. So I'm talking about batch 1 as 20, average of 1 as 45, quantity 2 as 30, average of 2 as 60. Let's use the formula. Quantity 1 by quantity 2 is 20 by 30 or 2 by 3. This would have been equal to difference of, since 30 was in the denominator, difference of 60 with the average, whatever that average is. We know it's 54, but let's calculate it now using this formula. So 60 minus the average that we need to calculate, divided by average minus the value for batch 1, which is 45. So this is what you always need to do, just reiterating it again, that if it's 20 by 30, so quantity 1 by quantity 2, in the numerator, you have the average of 2 minus the average, and in the denominator, you have the average minus the average of 1. Yeah, just make sure, that you don't get 1 minus and 1 positive. I mean, just make sure that the signs of both on the right hand side are correct. It won't be A minus 60 by 45 minus A, simply because the average lies between 60 and 45. So just that's something you need to keep in mind. And yeah, that's all. Is this clear? Maybe let's apply this for the second question. Let's apply, oops, oh God. Okay, let's apply this for the second question, which is, let me share the PPT again. 18 kg of dal costing 37 per kg and 27 kg of dal costing 52 per kg. So 18 is quantity 1, rupees 37 per kg is average of quantity 1. 27 kgs is quantity 2, and average of 2 or average of quantity 2 is rupees 52 per kg. So quantity 1 by quantity 2 is 18 by 27. This is going to be, so the 27 wala mixture costed 52, which is the more expensive quantity. So this will be 52 minus whatever average we get, divided by the difference of average with respect to the 18 wala, which is average minus 37. If you solve this, you will get the same answer, which is 46 rupees 46 per kg. We were, of course, talking about average cost here. Yeah, is this clear? If this is clear, then I'm going to throw a lot of questions your way. Okay, excellent. Then please try the following question. Do you have any other on the slide here? No, nothing else on the slide. One second, guys. Sorry. In fact, let me just send it to you. Why all the time, John? I will just send these files to you. Yeah, I've just sent you a file, guys. I want you to try from that file question number. Please open the file. And please try the following questions. The questions I'm sharing on the board, on the chat, sorry. Yeah. Question 1, 3, 4, 11, 12, 13, 14. And maybe also, yeah, maybe another 2 questions. '19 and 20 as well. But you have to do this super quick. 1, 2, 3, 4, 5, 6, 7, 8, 9 questions. 15-minute ought to be sufficient. Maybe I could lighten your workloads. No need to try question 3. Apologies. I don't try question 3. As well as question, I think let me just take out the easy ones and give you the more difficult ones to attempt. No need to try question 13 either. It's very simple. Yeah, no need to try 3 and 13. Solve the other, please. And don't get stuck. If you get stuck, leave the question. We'll discuss it. Which question, Lakshay? No, it doesn't. Of course, it doesn't. It's a set of numbers means a set of numbers. It could be anything. It need not be consecutive numbers. In fact, here it will probably not be consecutive numbers. Yep. It's not consecutive numbers, Lakshay, no. It's just a set of numbers, a collection of numbers, and it could be, you know, any collection. Win, learn mental maths. Learn mental maths. So 5 more minutes, guys. Yeah, is 5 more minutes good enough? We've already taken 10. I can give you 5 more minutes, not more than that, please. Another couple of minutes, please, and not more, and let's just start discussing. I would want you to try question 19 and 20, was it? The last couple of questions. Yeah, I would want you to try 19 and 20, please. If you have tried the others, good, because you already discussed those types of questions. We haven't discussed 19 and 20 type of questions. So yeah, do try question 19 and 20 once. Please read them if nothing else. The answer key is of course given at the bottom of the sheet, but even if you haven't seen it, it's fine, because we are going to discuss questions now, and you can let me know if you have any problems or if you face any problem in any of the questions. Oops, sorry. Yeah. So any problem in question number 1? Any problem in question 1, guys? Okay, any problem with question number given? Okay, Vinay 4 and 12. I hadn't asked you to do 3 nor 4. Yeah, 4 is a good question. 4 is a decent question, not the most difficult of questions. So yeah, it's a good, simple question. Okay, let's discuss 4 then. See, what does 4 say? A set of numbers is an average of 50. The largest element is 4 greater than 3 times the smallest element, which essentially means the following: 4, 12, 19. I will definitely discuss 19. I have to discuss 19 and 20 both. Briefly 20, but yeah, I have to discuss that. In 4, this is the sort of equation you have. The largest number is 3 times the smallest plus 4. 4 greater than 3 times the smallest. Now, if the average is 50, what you must understand when you hear the term smallest and greatest is that the greatest number, the largest number, L here, has to be greater than 50, and 50 has to be greater than the smallest number. The only way you can have an average of 50 is, one way is of course that all of them are at 50. The set of numbers have value, all values are 50. In that case, you don't have the largest and the smallest value. But when you do have a largest and the smallest value, when you have difference in values, the largest value will be more than average and the smallest value will be less than average. Which means that the largest value cannot be more than, so the largest value will have to be less than 3 into 50 plus 4. If smallest is less than 50, even if I were to keep it at 50, say, the largest will be 3 into 50 plus 4, less than this, which means the largest has to be less than 154. And if you look at the options, guys, the only option that just doesn't sit well with this equation is of course 155, option E. Largest is less than 154, but this option E, is more than 154. What does that mean? That means it's not possible. Krishna, okay. Yeah. The largest number is 3 times the smallest number plus 4. That's the equation we have. Since the smallest number is less than 50, it could be 49.9999. We don't know that. It's less than 50. So even if I were to keep the smallest as 50, just to check, let's keep smallest as 50. We find that the largest can be as far as much as, but definitely less than 3 times 50 plus 4, just using the equation. So the largest has to be less than 154. It could be close, maybe, we don't know. It definitely can't be beyond 154. And option E in the question given was more than 154. Check the options again. Check the option again, so you'll realize that option E, 155, is not possible. Is this clear? Well, what we've done is mathematical, Krishna. What we did here on the board is mathematical. I didn't get 3 into something. Why don't you read the question again? Please have a look. Here it is. If the largest element is 4 greater than 3 times the smallest. So largest is 3 times the smallest and 4 greater than that. So 4 plus 3 times smallest on the whiteboard here. 4 greater than 3 times the smallest. So, yeah, Krishna, go ahead.
Sir, can you hear me?
I can hear you.
Yeah, I didn't get how the larger number cannot be more than 3 into 50 plus 3.
Did you understand this equation 1 on your screen now?
No, that's where actually. Yeah, equation. I mean, first equation is given in the question.
It's given in the question. Yeah. What I am saying is, if a set of numbers, let's say A, B, C, D, E, also the smallest number S, some other numbers, also the largest number L, if the average of these numbers is equal to 50, it means without a shadow of doubt that either all numbers are 50, which is not the case here, and if all numbers are not 50, then the largest number has to be more than 50. You get an average of 50. If you remember what we discussed in the very beginning, that average is essentially zero deviation. Yeah. So if a number is more than 50, then it has to balance the numbers less than 50. For the largest number of a series that of a set of numbers that are an average of 50, largest will be more than 50, smallest will be less than 50. So even if I were to take the smallest value equal to 50, let's say, just let's take the smallest number is also equal to 50 or close to 50. Even then, the largest number can be as much as, use equation 1 here, it can be as much as only 3 into 50 plus 4, 154. Yeah, Umesh has done a good job. S is less than, yeah, okay, cool. Thank you, Umesh. Okay, cool. Let's jump to question number 12. I think someone had a problem with question 12. So I'm discussing 12, 4, and 19, and yeah, 20. I will talk about 20 also a bit. Now, what does 12 say? 12 says what is the ratio in which water should be mixed with with Coke concentrate, costing rupees 15 per liter, to make a profit of 30% by selling the resulting drink at rupees 18 per liter. This should be a question mark at the end, of course, but it isn't there, which is okay. So there are essentially two mixtures. If I were to interpret this, if I were to use my formula, what I could have done here is I can take two mixtures. So mixture 1 is the Coke concentrate. Let's say its quantity is Q1, and its cost is clearly rupees 15 per liter. Average cost of 15 per liter of mix 1 of quantity 1, of item 1, let's say. And the 2 is water. We are mixing water with this. Let's say its quantity is Q2. Now, an assumption here is going to be that water is free. In this question, you will take that water is free. No price for water has been mentioned. There's nothing wrong here with assuming water is free. I would expect it to be given in question. Water is free, maybe in a bracket. But yeah, you can assume that here. Is that okay? And when you mix these two, you are going to get some average price. You're going to get a mix. You're going to get another mix that has, of course, quantity Q1 plus Q2 and a certain average price A. Now, this average price is not 18. Because these were the cost price. Rupees 15 was the cost price. 0 was the cost price. So the A average is going to be the average cost price. What we have as 18 is the selling price. Rupees 18 is the selling price of the mix, which is obtained after 30% profit. So essentially that means that rupees 18, my selling price, if you remember, to do it directly is 1.3 times the cost price. The cost price of the mix, which I can also say is the average cost price of the mix. Did you understand this? Is this clear? Is this clear, guys? 1.3 times. If you remember, SP is nothing but CP plus profit, and profit is 30% of CP here, which means CP plus 0.3 times CP, 1.3 times CP is equal to 18, which makes you get this, which help you will help you get this. CP is nothing but 18 by 1.3, which is 180 by 13. This must be the average cost price of the mix, A. This is what A here is, 180 by 13. Which therefore means that Q1 by Q2, the ratio. Let's go back to the question. If you have a look at the question again, the question wants you to calculate the ratio in which water should be mixed with coke concentrate. The ratio with which water should be mixed. So since water is Q2, let me change this to Q2 by Q1. Since this is what we finally need, let's just focus on this. Q2 by Q1 is going to be, if you remember, so Q1's difference from the average, Q1 is rupees 15. 15 is more than 180 plus 3, of course. So Q1's difference from the average, 15 minus 180 by 3, sorry, 180 by 13, divided by Q2, the second quantity's difference from the average. Q2 is, of course, 0 rupees per liter. It's free, so it's going to be 180 by 13 minus 0. If you solve this, you will get the ratio of water, the ratio in which water should be added to the coke concentrate. Just solve this. That is all you need to do. And this will come out to be 15 into 13 is 195. So 195 minus 180. So the 13 will get cancelled out in any case upon 180. And that will give you, of course, 15 by 180, which happens to be 1:12, 1 by 12. So for every 12 liters of the coke concentrate, you add 1 liters of the water concentrate. Is this clear? 1 by 12 ought to be the answer. And I think the answer key will sort of give you the same. Is this clear? Any doubts here?
Abhishek sir, Krishna here.
Yeah.
Yeah. This method is okay. The other way around, it's almost the same method.
Sorry?
I'm stuck in other way without keeping the.
Without, sorry?
I'm stuck in middle.
Your voice is not clear, Krishna. Sorry, your voice is not clear.
Can you hear me now?
Yeah, but it's very. Yeah, go ahead.
Yeah. The cost price. The cost price has to be for a profit of 30%. The cost price has to be 180 by 13.
Yeah.
Right.
Yeah.
Yeah. The actual cost price for him for 100% purity is
15.
Yeah, 15, which makes 195 by 13.
Yeah.
Yeah. So the 195 by 13 has to be diluted in such a way to get 180 by 13. So he has to dilute somewhere around 15 by 13.
15 by 13.
Yeah, he has bought at 195 by 13, but he has to sell that at 180 by 13 by mixing water.
He has bought it at 195 by 13. Yes, that's correct.
Yeah, but he need to sell that at a lesser price, which is 180 by 13.
Mm-hmm.
The difference is 15 by 13. So 15 by he has to add water in such a way that the cost price should come down to 15 by 13, which
That's
means
absolutely correct. Yeah.
Yeah. So if I write it, 195 minus 180 is 15. So 15 by 13 should be the water added.
Krishna, are you stuck here or are you sharing this?
I'm stuck. No, I'm stuck here.
So you know, what you've done is absolutely what you have done and what we have done is exactly the same. If I were to not cut out, you know, look at the whiteboard now. If I were to not cut out the 13 here, we would get the same answer that you are getting in a slightly different manner. And just do it here. So since water will be 15 by 13, yeah,
Yeah.
being added in coke concentrate, that is 180 by 13.
Right.
So the ratio of water to coke concentrate is going to be 15 by 13 is to 180 by 13, which is exactly what we would have got here, you know, had I not cut out 13. It's exactly the same answer, 1:12.
Sorry, what were the ratios? 180 by 13 is to 15 is to 13.
15 by 13 belongs to water, sort of. It's the influence
Okay.
of water in the cost, in the selling price rather, in the price. And 180 by 13 is the influence of the actual coke concentrate, which will give me
Okay.
1:12.
Yeah. Thanks. Okay. Yeah.
Okay. Um, if you understood the first method, guys, this is good enough. It's almost the same. It's not very different. So I don't want you to be confused if you know if you found the if you didn't understand what Krishna shared, which is also absolutely the correct way of doing things. There's nothing wrong with it. Jumping to question number 19. 4 liters of wine are drawn from a cask containing 40 liters and replaced by water, and the process is repeated 3 times. What is the final quantity of wine in the cask? Um, Firstly, here, guys, Anubhav, I'm not going to uh, share the alligation method. If you know, if what you have in mind is the alligation using diagrams, I will not do that here, simply because you don't need it. The formula that I had shared is already a step, sort of miscellaneous step that you probably won't need for GMAT, but I think it's good to have as a tool. So the alligation method is, you know, is given in the diagram below. This is what alligation method is. So that is more than sufficient. It may seem better than easy, yeah, but I don't want to get into that, to be honest, right now. Okay. We were talking about question number 19. I just want to quickly share this with you. So, you know, you had 40 liters of wine. And from this, 4 liters of wine are being taken out and 4 liters of water is being added. This will obviously give you a certain quantity, which is very simple to calculate. You'll still have 40 liters of solution now, which would have 36 liter wine and 4 liter water. And thereafter, again, 4 liter of solution is being removed and 4 liter of water is being added. And then you'll again have some mixed. You'll always have 40 liter of solution. Yeah, what I want to share here is, if I had to see how much water and wine is being taken out from this 4 liter solution, it will be in the same ratio. 4 liters of mix is removed, or 4 liter of mix. The first time it is 4 liter of wine because the mix is only wine, but thereafter it is 4 liter of the mix. of 4 liter is going to be water removed. And of hello. Hello, I don't know what happened. I think there's probably some problem with internet, maybe, I don't know. That's the only thing I can guess. So yeah, unfortunately, we'll have to do the whole thing again very quickly. So yeah, this is 40 liter wine. So maybe I can give you the, rather than doing it each time. What I want to say here is, every time 4 liter is removed, whether it's completely wine or solution, and then some 4 liter of some other quantity is added, 4 liter of water was added, then you get another solution that has 40 liter, and then again 4 liter of the solution is removed and 4 liter water is added, and this process goes on tons of times. What is essentially happening is 4 out of 40 liter is being removed, which means 1/10 is being removed, which means 9/10 is being retained. Yeah. So after operation 1, if I have to look at like in this manner, take this approach, at 40 liters wine, 4 liters was removed, which means 1/10 was removed, which means 9/10 was retained. I must have this quantity, 36 liters. Yeah. In the new solution, in the second picture, 36 is wine. Now again, since 4 liters out of 40 liter is removed, it means that again in the second time 1/10 is removed, which means how much is retained? 9/10. And since the quantity being added here is water and not a wine, it means after the second operation, this 40 into 9/10 into 9/10 is going to be the wine present, the amount of wine present. And this is going to continue. If the same process were to happen one more time, you now have a certain quantity of wine and water. And if again 4 liter of solution were removed and water were added, then another 9/10 times another 90% of wine would be retained and 10% would be lost. Is this clear? And this would keep on happening depending on the number of operations you take, sort of. Is this clear, guys? So if this process happened in total, say 3 times, then quantity of wine, Q wine means quantity of wine present at the end after this has happened 3 times. If this process is going to be 3 times, it's going to be 40, the initial quantity, into 9/10 times retained after operation 1, into 9/10 after operation 2, after the same process has been carried out the second time, into 9/10 that the third time the process has been carried out. This has to be your quantity after 3 operations. Is this clear? So this happens to be 729/25, I guess that's what it's going to be. 9 cube is 729, 40 by 1000 is 25. You can calculate, it's not very difficult to calculate. Is this clear, guys? Is this clear? Excellent, excellent. I could give you a formula for this as well, although you will probably not need it. Okay, let me share the formula very quickly with you. So, the quantity, and this only works, the quantity of the solute This only works for a solute. This only works for the quantity that is not being replaced, that is not being added again. So this formula wouldn't work for water. In the previous question, this formula would work for wine. This is equal to the initial quantity into 1 minus quantity removed of the solution upon initial quantity to the power n, where of course solute is the thing, the item not being removed. Q initial is the volume of that solute. Quantity removed is the quantity being removed every time. So this formula holds for a repetitive process. Since if you remember, this was 4 liters and this was 40. 4 by 40 was 1 by 10. So 1 minus 1 by 10 gave you 9 by 10. If you remember what we've just done, we kept multiplying by 9 by 10. And the power n is, of course, the number of times the same operation is carried out. Number of operations, let's just put it like that. This is what the formula is. Do remember when this formula works. Yeah. I hope this is clear, guys. Okay. Question number 20. The only thing I want to mention in question number 20 is this. You could have solved it using our, this thing, the formula we had discussed. Q2 by Q1 is nothing but the inverse of, the difference of averages. So difference of average of quantity 1 minus the overall average upon the difference of average from average 2. Inverse of the difference of averages is what Q2 by Q1 is equal to. You could have solved it using this formula, where 12 liters is the total quantity, is the total quantity of the mixture. You are mixing two quantities you're mixing two sort of mixtures, 2 cans of milk of quantity 1 and quantity 2. 12 liters happens to be the final quantity of the mixture. And you could have used the formula, but if you realize the values were, the first can has 25% I think water, was it, or was it 25% milk? It was 25% water. Yeah. So for the first solution had 25% water, the second one had 50% water, and the average was 3:5. 3 was water, 5 was milk, which means that the average water was 3 out of 8 parts, which in percentage terms means 3 by 8 into 100, 37.5%. Yeah, which means you're mixing can 1 with 25% water with can 2 50% water to get 37.5% water, which is perfectly in between. It's the arithmetic mean of 25 and 50. That is only possible if the same quantities are mixed. So if you're taking X liters of this, you would need to take the same quantity X liters to get the concentration as the perfect average, the arithmetic mean of 25 and 50. This is just one small thing that I want you to keep in mind. So if you just realize what these values were, you would immediately say that if 12 liters was total, that would mean that I would need to mix 6 liters of can 1 with 6 liters of can 2 to get average concentration. That is the arithmetic mean of the two concentrations. Is this clear? Okay. Okay, cool.